Introduction to Green Building. Green building is the practices of creating structures and using processes that are environmentally responsible and resource efficient throughout a building life cycle. Our proposed building is Block B11. Faculty of Built Environment. University of Technology Malaysia. This is front elevation of B11. Back elevation. And some sort of landscape picture of B11. Block B11 were chosen because it has poor soundproofing between room in it, highly used electricity especially lighting and air conditioning purposes, poor in natural lighting, and highly used of water resources. There are 6 elements to be sustained for this building, which is indoor air quality, energy efficiency, glazing, rainwater harvesting system, photovoltaic, and green material. Indoor air quality means that chemical composition of indoor air is clean and fresh. In terms of material, we propose that zero VOC paint used for this building, such as for wall defects, to improve indoor air quality. Our proposed locations are: first, the measurement studio. Second is lecture room. And third location is computer lab. For clean air, we propose that filtering will be used for this building to obtain clean air. Filtering function to eliminate the impurities that come from outside air and will keep indoor air fresh for occupant comfort and productivity. Our proposed location for filtering are: first, lecture room. And our second proposed location is computer lab. What is energy efficiency? Energy efficiency is using less energy to provide the same service. 1. Proposed LED lighting, for Bilik Kuliah. The exchange of fluorescent lamp to use LED lamp. Advantages of light emitting diodes: long operating life, very low energy, low maintenance costs, and small designs. 2. Install the light sensor, such as for toilet, Bilik Kuliah, and add gallery. The benefit of light sensor can be turning lights on automatically, and reduce lighting energy. 3. When you replace an appliance, such as a computer, with a more energy efficient model. For computer lab at B11, use efficient computer monitor, standby power controllers, SBCs, and use computer monitor energy rating labels. This appliance can be saves money on energy bill and reduces the amount of greenhouse gases going into the atmosphere. Glazing concept for Studio 2 and Studio 4. Problem of sunlight directly into Studio 2 and 4 in the morning and evening. Glazing now using normal tinted. Normal tinted problem is easy crack, bubble or fade, and not thermal insulation the best possible. Let's turn to liquid nano tint for glazing Studio 2 and Studio 4. What is liquid nano tint? Thermal insulation is coating ideal for single pane glass and applied like a paint. Capable of blocking 100% of ultraviolet rays, up to 95% of infrared rays, and maintaining up to 78% visible light transmitted. Advantages of liquid nano tint: with the ability to mitigate both radiant and conductive heat. Liquid nano tint can effectively keep indoor environments cooler in summer and prevent heat loss in the winter. Nano tint is easily applied with a paint roller, which makes it the ideal choice for retrofitting. Rainwater harvesting system. Rainwater harvesting system is the process of collecting, conveying and storing water from rainfall in an area for beneficial use. This method is less expensive and very effective, and if implemented properly helps in augmenting the groundwater level of the area. How does it works? It is a system of catching a rainwater where it falls. In rooftop harvesting, the roof becomes the catchments, and the rainwater is collected from the roof of the building and directed to the filter through water-down pipe. The filter will remove silt, dust, leaves and other organic matter from entering the storage tank. The filter media should be cleaned daily after every rainfall event. The water in the storage tank is then pumped to the high-level storage tank. Now the water can be supplied to the building, which can be used for cleaning and agriculture purposes. There is one issue that happens in this building when rain. Rainwater overflow down into the building because the building is located in a low area. What can be done to solve this problem by using sustainable construction methods? Yes, pervious concrete. Pervious concrete has a system in which a mixture of stone and cement only, just a little sand is used or not. This pervious concrete creates porous space to allow water to pass through it. Rainwater will enter the pervious concrete, then flowing into the subsoil pipe. Subsoil pipe will stream water to the existing drain. Last but not least, the sustainable element that will be applied is photovoltaic system. It has been chosen due to its efficiency in controlling the energy source. The grid-tied system will be used to this building that works in with the local utility grid, so that when the solar panels produce more solar electricity, it will be using the surplus power to feed into the grid. There are 4 basic components used in this system, and here are the example of how does it work. Firstly, the solar panel will function as the sun energy collector. Then, it will transport it to the grid-tie inverter to transform the energy from direct current to alternating current for daily use. After that, the alternating current from the inverter will be transmitted to a building's distribution panel, which effectively reducing the amount of power drawn from the utility grid by the connected appliances. Next, the current will pass through the utility meter to record the amount of power produced or used. The last stage is the excess solar electricity is funneled back into the power grid. Indirectly, the application of a solar photovoltaic system at this building could be substantially beneficial for all parties involved, especially to the lecturers and students. Solar has become one of the fastest growing renewable energy sources. It provides an excellent solution to the issue of our diminishing resources. Solar also provides energy security because it is harvested from our most abundant resources, the sun. Besides that, the operating and maintenance costs for PV panels are considered to be low compared to costs of other renewable energy systems. Solar energy does not release any harmful carbon dioxide, CO2, or other pollutants as traditional electricity generators do. Implementing more solar energy on this building or even the whole campus will provide ample learning opportunities for the student on how they can be more sustainable in their own personal lives. Conclusion. Our proposed building for sustainability is B11, FAB. Benefits of sustainability. For environment. First, enhance and protect biodiversity. Second, improve air and water quality. For economic. First, reduce operating cost. Second, improve occupant productivity. For social. First, improve quality of life. Second, enhance occupant comfort and health. Thank you.